All right, so today we're going to talk about something that's, well, it's pretty much invisible, but it runs almost everything. We're talking about the Linux system. And the story behind it is just wild. It's all about collaboration, this idea of being radically open, and a couple of really smart design choices that honestly ended up powering our entire digital lives. So you got to ask, right? How did a simple student's hobby project end up basically taking over the world? Let's dig in.
Okay, so first slide up and it's a dinosaur. Yep, a Carnotaurus. And I know exactly what you're thinking right now. Wait, didn't he just say we were talking about a computer operating system? You're not wrong to be confused. Just hang in there with me. I swear this is going to make sense later. Kinda.
So yeah, that's the big question, isn't it? What in the world does this prehistoric meat eater have to do with the software that's running, everything? Your phone, the internet, the world's biggest supercomputers, all of it. To figure that out, we do have to go back in time, just, not quite that far back.
All right, let's get into the real story. We're not starting in the Jurassic period, but in a time that, let's be honest, can feel just as ancient to some of us, the early 1990s.
And this is where it all kicks off. Back in 1991, there's this student in Finland, Linus Torvalds, and he starts what he literally called just a hobby. He wasn't setting out to change the world or anything. He just wanted to build his own operating system kernel. And a kernel, if you're not familiar, is basically the absolute core of an OS. It's the engine. He wanted to build one for his own PC, kind of modeled after the big, powerful Unix systems he was using at his university.
And that little hobby project? Well, it didn't stay little for long. It just took off, like really fast. It stopped being one guy's personal project and exploded into this global collaboration, pretty much all happening over the internet, which, you have to remember, was a pretty new and wild thing back then.
And what's just nuts is the speed of it all. Look at this timeline. You start in 1991 with version 0.01. It's a bare-bones kernel, can't do much, can't even get on a network. Flash forward just 3 years to 1994, and boom, Linux 1.0 has full-blown networking. 2 years after that, with version 2.0, it's not even tied to PCs anymore. It's multi-platform, it's handling 64-bit systems, multiple processors, the whole shebang. It went from a toy to an absolute powerhouse in 5 years. That kind of development pace was just unheard of.
So what was the secret sauce? What made it so powerful, so fast? To really get it, we've got to pop the hood and take a look at a couple of super clever design choices right inside the Linux kernel.
This diagram here really shows you the whole picture. See that core? That's the Linux kernel. Everything, and I mean everything, sits on top of it. You can think of the kernel as the ultimate manager, or maybe like the brain of the operation. It's handling the hardware, the memory, every single process. It's the central hub that makes all the other stuff work.
Okay, so a huge part of managing all that stuff is how you create new tasks or processes. And this is where Linux gives programmers some serious control. You've got fork, which basically says, hey, make an exact, brand new, totally separate copy of this process. But then you have clone. And clone is different. It creates a new process, but one that shares stuff, like data, with the process that created it. This might sound a little technical, but that level of control is absolutely critical for building really efficient, modern apps that do a million things at once.
And check this out. Here's another brilliant little trick for staying efficient. It's all about how Linux deals with interruptions from your hardware. Like when you click your mouse. Instead of just stopping the world to handle it, Linux splits the work in two. It's like emergency room triage. The top half rushes in and does only the most critical life or death stuff right now, and it tells everything else to be quiet for a split second. Then it schedules the rest of the work, the bottom half, to be done a moment later, once everything is back up and running. It's such a simple but elegant way to make sure the system always feels fast and responsive.
But look, the tech details are really only half of it. To really understand Linux, you have to get the philosophy behind it, which is just as important. It was never just about writing code. It was about how that code was going to be shared with the world.
And this right here is the legal engine that powered the whole collaboration. It's called the GNU General Public License, or GPL. And the main rule is actually pretty simple, but at the time, it was revolutionary. Think about it, this was the era of Microsoft enclosed software. The GPL says, basically, hey, you can use this code for free. You can change it, you can improve it. But if you do, you have to share your new version with everyone else under the exact same open terms. It's like a pay-it-forward license for software. You can't just take it, lock it up, and sell it as your own secret product. And that one rule guaranteed that Linux would always belong to the community, always getting better because everyone was sharing their improvements. So, since this kernel was totally free for anyone to grab and use, it led to this amazing new thing, distributions, or distros for short. The best way to think of them is like a complete operating system meal kit, you know? They take the Linux kernel, that's the engine, and they package it up with all the other ingredients you need. The tools, the apps, an easy installer, everything you need all in one ready-to-go box.
And remember our dinosaurs from the beginning? Well, here's the payoff. Just like real dinosaurs evolved into all these different species to fit into different roles in the ecosystem, the world of Linux distributions did the exact same thing. You got your big commercial carnivores like Red Hat, who package Linux up and sell it with support contracts to huge companies. And then you have your community-driven herbivores like Debian, which are built and maintained completely by volunteers. They're two totally different ways of doing things, two different philosophies, but they both evolved from the exact same open-source DNA. See? I told you it would make sense.
Okay, so let's pull all these threads together for our last section. Because these choices, the tech stuff, and the philosophy stuff, they weren't just cool ideas. They were basically a recipe for taking over the world.
So when you boil it all down, you see what made Linux win. It was built from day one with these core principles in mind. It had to be fast, it had to be efficient, it followed the rules of the road, the existing Unix standards, so it felt familiar and super reliable to developers. And, maybe most importantly, it was built from the very beginning to be a real multi-user, multitasking system. It was designed to juggle a ton of users and a ton of tasks all at the same time without breaking a sweat.
In that solid foundation, that's why this little hobby project is now literally everywhere. Its insane reliability and efficiency made it the no-brainer choice for the servers that run the entire internet. Its stability is trusted by places like the world's stock exchanges, where you just can't afford a crash. And its raw number-crunching power is the engine behind pretty much all of the world's biggest supercomputers. And it all came from that one student's project. It's just incredible.
So let's end with this question. The story of Linux is this amazing reminder that the next world-changing technology doesn't have to come from some giant billion-dollar corporate lab. Sometimes it just starts with one person, with a passion, with a little bit of curiosity. It really makes you stop and think, doesn't it? What's the next great hobby being built in a dorm room or a garage right now that's going to be running our world 30 years from today?